So we're going to review how to solve systems. You did learn this in Algebra 1, but there are three ways to solve systems. And as a review, systems are when you have two or more equations and you need to solve them. So the first way we are going to review is by substitution, and I'm going to go ahead and zoom in here. The substitution method works best when we already have a variable by itself. So in this case, x is already by itself. So I'm going to put a box around what x is equal to, y plus 7. So now whatever is in this box, I'm going to substitute for x in the second equation. So I'm going to now rewrite this and say y plus 7, and then we have plus y equals 5. Now I can combine my like terms. So y plus y is 2y. I still have my plus 7 is equal to 5. Now I just need to solve for y. I'm going to subtract the 7. I get 2y to equal negative 2. Divide by 2. And I get y to equal negative 1. So I'm not going to put a box around it, but I am going to circle it because it's important. So I'm going to zoom back out here. So now I have y equaling negative 1. But a solution to a system, you have to solve for both letters, both x and y. Well, now that I know that what y is equal to, I can take that letter and plug it in to my box. So now to find x, I can say x is equal to negative 1 plus 7. So x is equal to 6. Again, this is not my final answer. My final answer is always written as a coordinate point. So parentheses x, which is 6, comma, y, which is negative 1. So my solution to that system is 6, negative 1. And that is using the substitution method. I'm going to zoom back in so we can talk about the second method, which is the elimination method. Now the elimination method is a little bit harder, but not that bad. It is faster. In order to do the elimination method, you need everything lined up. So you need the x's in a line, the y's in a line, your equal signs, and then whatever it's equal to. They all have to be matched up. In this case, it is. I am able to use the elimination method here because I have the same letters but opposite numbers in front. So I have a positive 3 in the front on the top one and a negative 3 in the front on the bottom one. So same letters, same numbers, opposite signs. The reason why I can now do my elimination method is when I add straight down, I get 2x plus x, which gives me 3x. Positive 3y plus a negative 3y cancels out. Carry down my equals. 7 plus negative 1 is 6. Now we can divide by 3, and we get x to equal 2. Again, not my final answer, but it is important. Because now to find my final answer, I need to plug 2 back in for one of my original problems. So I'm going to erase everything I have up here so I can see my original problems. You don't have to erase it. So now I need to take this 2 and plug it in for either x. It doesn't matter which one you use. I'm going to use the bottom one because x is by itself. So I'm going to plug that 2 back in for x. So now I have 2 minus 3y equals -1. Now I need to solve for y. So subtract 2. And I get -3y is equal to -1 minus 2 is -3. Divide by -3. And I get y to equal +1. So my answer is written as a coordinate point, which is x comma y. So 2 comma 1. And there's my final answer. Now, the third and final way to solve these systems is by graphing. You can do it by hand, and I'm also going to show you how to do it on Desmos. Luckily for us, both of these are in our y equals mx plus b form. So they're pretty easy to graph. Remember, m is equal to your slope, and b is equal to your y-intercept. So for my top equation, I'm going to do that in green. My y-intercept is -3. So I'm going to go down 1, 2, 3. Plot that point. My slope is the number in front of x. So in this case, it's a 1, which means I'm going to go up 1 over 1, up 1 over 1. And I can go the other way too, down 1 to the left 1. And I'm going to cheat and use my lines. So the top one looks like this. I'm going to do the bottom one in blue. So -6 is my b. So I'm going to go down 1, 2, 3, 4, 5, 6. Slope is 1/2. So I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. I'm going to connect my lines. So if these lines were to continue to go, I know I don't have enough room on my grid, they would eventually intersect. The intersection is your solution. That's what all these points that we have found. So in my substitution, these two lines will intersect at 6, -1. In my elimination, these two lines will intersect at 2, +1. Graphing, I have my picture, but I can't see where they actually intersect. So I am going to go to Desmos. And if you need a minute to get Desmos up, make sure you pause this video. I'm going to type each equation into Desmos. So y equals x minus 3 is the first one. And then y equals 1/2. X minus 6 is the second one. So now, just like what we saw on our paper, I'm going to click and drag down so I can see where they intersect. And so my intersection point is at -6, -9. So my solution to my third one is -6, -9. In parentheses, I'm going to put a box around it because that's my final answer. So those are the 3 ways we learned in Algebra 1. Let's do a few more examples. You can choose any method you want to. I do not care. I'm going to zoom in here so we can see number 4. Okay, I have 3x plus 8y equals 8 and 2x plus y equals 1. So here I don't have any letter by itself, so substitution isn't the best. Here I do have my x's and my y's and my equals. They're all lined up, but I don't have opposite numbers, so that's kind of hard. So I could do graphing, and this is what's great about Desmos. Desmos, you don't need it in y equals. We can just type it in exactly as we see it. So I'm going to get rid of both of these. I'm going to type in exactly what I see. So go to Desmos, and we got 3x plus 8y equals 8. And then we also have 2x plus y equals 1. I can just click and drag up until I find my intersections. And here I have my intersection of 0, 1. So that is my answer for number 1. Parentheses 0, comma 1. All right, let's go over to number 5. Again, number 5, you could do this by graphing, and that's completely fine. If you would like to, you could do all 4 of these by graphing, but it is good to get in the habit of practicing the different methods. With number 5, I notice I have y by itself, so I could box this and plug it in for the y in the second one. So this would become 8x minus 5, and then parentheses 2x minus 4 equals 9. Now to simplify this, I'm going to distribute the -5. Now I have 8x minus 10x plus 20 equals 9. I'm going to combine my like terms. 8x minus 10x gives me -2x plus 20 equals 9. Subtract my 20. And I get -2x to equal -11. Divide by my -2. And I get x to equal positive 11 over 2. So there's my first part. Now I need to take that x I just solved for. I'm going to plug it back into my box to figure out what y is. So y equals 2 times 11 over 2 minus 4. Well, remember, anytime we multiply a fraction by the bottom number, they cancel out. So 2 times 11 over 2 becomes y is equal to 11 minus 4. Then we have 11 minus 4, so y equals 7. So my answer here as a point is parentheses 11 over 2, comma, 7. If you did this by graphing, go back here, I'm going to type in my 2, and I've got equals 2x minus 4. And then I also have 8x minus 5y equals 9. I can see where they intersect at 5.5 comma 7. When dealing with graphs, decimals are okay. I will allow them. If you would rather deal with fractions, you could take your decimal of 5.5, type it into Desmos, and then notice here, if we hit this button, it will turn it into our fraction, 11 over 2. So again, any method is acceptable for solving these systems. So we do have 2 more, and you can solve these whichever way you would like. I see another one with substitution. So I'm going to go ahead and put my box around this, and I'm going to substitute it in for the y in the second one. Let me zoom in here. So now I have 3x plus 4 minus 3x equals negative 2. I'm going to combine my like terms. So 3x minus 3x, that gets rid of all of my x's. So that leaves me with 4 equaling negative 2. But that doesn't make any sense. 4 will never equal negative 2. So my actual answer for number 6 is no solution. And if you did this by graphing, systems that have no solution mean there's no intersection, also known as parallel lines. So again, I'm doing number 6 in Desmos. And the first one is y equals 3x plus 4. And then the second one is y minus 3x equals negative 2. And we can see these are parallel lines. No matter how much we drag or if we zoom out, they are parallel lines. So there is no solution. All right, now let's look at our last one, number 7. Number 7, you could do substitution, and that's completely fine because you have x by itself, and you just plug it in for the x up here. I'm actually going to do this one by graphing. So I'm going to go to my Desmos, and I'm going to type in the first one, which is y minus 2x equals 1. And then the second one, we have x equals, now I need the entire top of this next part to be on my fraction. So I'm going to do parentheses, y minus 1. And then if I hit my little keypad down here, I can hit the division sign, and that will give me a fraction. Or if you hit your question mark button on your computer, that will also give me a fraction. And we're dividing it by 2. Now, notice over here what happened. My graph changed colors. So I'm going to delete that second one so you can see it again. My first one, and you can look next to it, is black. It is a black line. When I go to type in my second one, which is x equals, then I have y minus 1 on top over 2. Now it turned to a blue line. If you click it, it goes away, which means these are the exact same line. And when something is the exact same line and they are graphed, that means they are always intersecting. My blue line is on top of my black line, so it's constantly intersecting. So if it is constantly intersecting, that means my answer to number 7 is infinite solutions. And that is your recap with solving systems. Make sure you come and see me if you have any questions.